At my direction, the United States Air Force is moving forward with the world's first sixth-generation fighter jet. Nothing in the world comes even close to it, and it'll be known as the F-47. The generals picked a title.
Every advanced fighter in American history was built around a set of rules. Rules about how far it could fly. Rules about how fast it could push before its own coatings started to peel. Rules about whether a single pilot could fight alone, who built the airframe, how the program was managed, how few of them had to absorb the losses of a peer-level war, and whether the winning contractor got to keep winning forever. In 1990, when the Advanced Tactical Fighter program produced the F-22 Raptor, those rules were rational. They mapped to a Cold War threat geometry, a defense industrial base with multiple competing primes, and a propulsion physics that said you could be fast or stealthy, but not both. In December of 2024, those rules got photographed in flight over Chengdu. China's J-36 and J-56th generation prototypes were not iterations of the F-22 paradigm. They were clean-sheet designs built specifically to defeat it. But the real story is not the J-36 reveal. The real story is that for 5 years before that photograph was taken, America had been quietly building a fighter that violated every single rule the F-22 had been built around, and on March 21, 2025, the United States Air Force admitted it. This is the F-47. And what follows is the rule-by-rule case for why the air power doctrine the United States has operated under for the past 2 decades is structurally dead. Welcome back to the channel. What follows comes straight from official Air Force statements, the March 2025 program announcement, and the public contract record. By the time this video ends, you will know the 8 rules the F-22 was built around, the moves the F-47 used to break each one, and the 3 risks that could pull the transformation apart. Rule 1 was that combat radius could be short because tankers would always be there. The F-22 Raptor's combat radius on internal fuel is between 460 and 590 nautical miles. The doctrine assumed KC-135 and KC-46 tankers could orbit just behind the forward edge of battle. The Pacific does not work that way. The People's Liberation Army Rocket Force fields the DF-21D and DF-26, missiles whose purpose is to push American tankers thousands of miles back from contested airspace. The F-47 severs the tether. Official Air Force statements place its combat radius at greater than 1,000 nautical miles, roughly double the F-22. The tailless aerodynamic design eliminates the parasitic drag of vertical stabilizers and unlocks massive internal volume for fuel. And the adaptive cycle engines, the Pratt & Whitney XA-103 or the General Electric XA-102, use a third stream of bypass air that lets the engine transition between high-thrust combat mode and high-efficiency cruise mode mid-mission, with cruise efficiency approaching commercial airliner levels. The adversary can still target tankers. The F-47's mission no longer dies when they succeed. Rule 2 was that speed and stealth were a binary trade-off. Push past Mach 2 in a stealth aircraft, and the radar-absorbent coatings peel, blister, or burn off. The F-22 supercruises, but its top speed is capped at Mach 2.25, and it cannot sustain that speed without thermal damage. The workaround was to abandon stealth. The MiG-25 Foxbat and the SR-71 Blackbird went fast by going naked. The F-47 engineers physics out of the equation. The airframe extensively uses ceramic matrix composites, materials that hold structural integrity and stealth properties past 2,500 degrees Fahrenheit. To manage the heat from those materials, the adaptive engines, and future directed energy weapons, the aircraft uses cryogenic cooling loops and a fuel-as-coolant architecture, treating internal fuel mass as a thermal sink. The aircraft can sprint at sustained high Mach across the Pacific while keeping its radar cross-section and infrared signature low. The thermal bloom has been engineered out at the materials level. Rule 3 was that every sensor, emitter, and missile lived inside the manned airframe. Every kill chain forced the pilot inside the lethal envelope of adversary surface-to-air missiles. The F-47 moves the pilot out of that envelope and into the role of a flying command node, the quarterback. Around it fly collaborative combat aircraft, the CCAs. 2 are already in the air. The General Atomics YFQ-42 Alpha, call sign Dark Merlin, flew first on August 27, 2025. The Anduril YFQ-44 Alpha, call sign Fury, flew on October 31, 2025. The autonomy architecture is government-owned at the framework level, the Autonomy Government Reference Architecture, with mission software like Collins Aerospace's Sidekick swappable across airframes. The Air Force target buy is more than 1,000 CCAs, with 2 CCAs per crewed F-47. Active sensors, electronic warfare emitters, decoys, and kinetic weapons get pushed forward onto attritable drones. The pilot is the conductor. Rule 4 was that one prime contractor would dominate American fighter development. Lockheed Martin built the F-22. Lockheed Martin built the F-35. The fifth-generation American fighter was a Lockheed monoculture. On March 21, 2025, the Department of Defense ended that streak. The $20 billion engineering and manufacturing development contract for the F-47 went to Boeing. The award reopened the St. Louis combat aircraft line, weeks from a quiet wind-down following the scheduled end of F/A-18E/F production in 2027, and triggered a multi-billion-dollar expansion of Boeing's Berkeley, Missouri facility, including a new 880,000-square-foot plant. 2 viable American sixth-generation primes are now in the field. The Lockheed monopoly is over. Rule 5 was that fighter programs ran in public. The ATF competition between the YF-22 and the YF-23 was a high-visibility fly-off. The F-47 ran in the opposite direction. On March 21, 2025, when the program designation was announced from the Oval Office, Air Force Chief of Staff General David Allvin released a written statement. Quote, "For the past 5 years, the X-planes for this aircraft have been quietly laying the foundation for the F-47, flying hundreds of hours, testing cutting-edge concepts, and proving that we can push the envelope of technology with confidence." End quote. 5 years of classified flight time, funded in part by DARPA's Aerospace Innovation Initiative, held inside Special Access Program compartmentalization so tight that engineers could not tell their families. The F-47 was announced as already mature. Rule 6 was that you needed mass. The original F-22 plan called for 750 airframes. Cost growth truncated that by to 187, an exquisite microfleet so few in number that commanders became risk-averse. The F-47 program of record is approximately 185 airframes. On the surface, the same problem. Underneath, the math is rewritten. With 2 CCAs per fighter and the over 1,000 aircraft CCA buy, a 185 airframe F-47 fleet generates 555 networked platforms. Advanced loadouts up to 8 CCAs per fighter project, a total of 1,500 distributed combat nodes. Losing a $300 million F-47 and its pilot is a strategic disaster. Losing a $25 million semi-autonomous CCA is a calculated, acceptable trade. The exquisite capability stays. The mass gets generated. Rule 7 was that a fighter program took 20 years. The F-22 ran from the ATF-RFP in 1985 to first flight in 1997 to initial operating capability in 2005. The F-47 abandons that approach for digital engineering, the Digital Century Series doctrine championed by former Air Force acquisition lead Will Roper. Inside Boeing's Phantom Works division, a complete digital twin was built and run through simulated combat for years before the EMD contract was awarded. Boeing's defense executive Steve Parker put it directly, quote, "There's no smoke and mirrors here. That digital environment, we are taking the risk out well ahead." End quote. Within months of the March 2025 contract award, the first physical test article was under construction. The first flight target is 2028. Operational fielding is targeted before the end of the decade, 3 to 4 years from contract to first flight. Rule 8 was that sustainment came later. The F-22 is the cautionary tale. Its 2022 Government Accountability Office cost per flight hour is $85,325. Early generation stealth coatings crack in desert sand and peel in high humidity, requiring up to 30 hours of meticulous maintenance for every flight hour. The F-35 sits at roughly $42,000 per flight hour. The F-47 treats sustainment as a foundational design metric, a built-to-adapt philosophy. The platform uses an open mission systems architecture that decouples hardware from software, allowing modular upgrades of sensors, electronic warfare suites, and weapons interfaces without deep structural teardowns. Distributed operations from austere Pacific Island airstrips become feasible. The architecture is engineered to receive software upgrades the way a smartphone does. The first risk is cost. At a reported $300 million per airframe, the F-47 is roughly 3 times the flyaway cost of an F-35A. Budget hawks argue the F-47 is structurally vulnerable to the exact death spiral that capped the F-22 at 187 airframes. High initial costs trigger congressional buy reductions, which destroy economies of scale. The 185 airframe target may not survive the decade. The second risk is Boeing execution. Boeing's defense division has spent the last decade producing the KC-46 tanker, plagued by years of delays, the T-7A Red Hawk trainer, which has itself missed schedule, and the Starliner crew capsule. The Air Force is betting that the F-47, born inside Phantom Works, escapes the wider quality control problems. The third risk is CCA doctrine maturity. The combat math depends on autonomy software working in heavily jammed environments specifically engineered by China to break secure data links. If adversaries sever the link, the F-47 becomes a $300 million flying command node forced into close-in engagements, a role for which it is not optimized. None of these risks is fatal. All of them are real. On the first road, the program holds. The 2028 first flight target is met. The CCA Increment 1 down select produces an autonomy stack that survives the contested spectrum. The 185 airframe fleet is funded through. The CCA buy passes 1,000. By the early 2030s, the Air Force operates a distributed sensor shooter network of more than 550 platforms. The rules are not just broken, they are replaced. On the second road, cost growth forces buy reductions, the autonomy stack proves brittle, Boeing execution slips, and the Air Force enters the 2030s with a smaller F-47 fleet facing a mature Chinese sixth-generation force. The decision is made inside Boeing's St. Louis facility and inside the House and Senate Armed Services Committees. The rules of the F-22 era are dead. The question is whether the United States has the discipline to write the new ones before the window closes. Before you go, if this rule-by-rule analysis is the reason you keep coming back, subscribe. That signal tells the algorithm to keep pushing long-form defense reporting in front of viewers who actually want to think about it. The next deep dive is already in the works. Until then.